Hey you guys, in this video we're going to go through the programming implementation of stacks. And in this specific video I want to cover just the constructors, the destructor, and our getter methods for our stack class. We'll worry about other general methods and operator overloading in future videos. So because I want this to be a generic stack and to be usable in various C++ files, what I'm going to do is that I'm going to make it do all the code implementation in the header file. So we'll have generic stack.hpp. So of course, because it's going to be a generic stack, I'm going to have to do my template, and I'm going to do type name S for stack. So we'll have our class. We'll call it stack with a capital S. And for our stack class, we're pretty much only going to have two members for it. We're going to have, I'll say a size t called size. Let's proceed it with an underscore. And then we're going to have our s, and it's going to be a pointer, and I'm going to say it's data. And this underscore data is going to be our dynamically allocated array, in which we will resize when we need to add data, and of course resize when we need to remove data. So I'm going to go with a unparameterized constructor, and with this, well, what I'm trying to do is that I'm trying to create a stack that's empty. So we'll have a size of 0, right? Because an empty stack is going to have a size of 0. And because there's going to be no data, I'm going to point my data to the null pointer. And then I'll also want to create a stack with a specific default value. So I'll have s value. So that means our stack is going to be created with a size of 1. And then, well, here what we're going to do is that we're going to dynamically allocate R1 data for it. So we'll need new s, and I'll have the value of value. Right, in this constructor we just take one s value, right? S can be an integer, a string, even a complex number, and we'll dynamically allocate one value being initialized to the value that we provide, and that'll be equal to data. I don't know why I set that equal to underscore value, right? But our data that's going to be pointing, our array containing our data, is going to have one data called value. So now I'm going to implement the copy constructor, so that'll take a constant reference to another stack, which we'll call s. So if the size of s is equal to 0, well then we know that size is equal to 0, and our data is going to be pointing to the null pointer, because there's nothing there. We're essentially copying an empty stack to another empty stack. However, now when it comes to our non-empty stack, what we're going to do is that we're going to copy the size of our s stack, and then we're going to create a new value, and I'll say s data is equal to, or s data copy, so that we know that it's a copy. So we're going to dynamically allocate what we need to copy our data from s to this temporary copy, and then from this temporary copy we'll copy that data to our stack that we're going to create. So here I'll have my iterator I, and actually no, let's do this, because I think our compiler will complain. And we'll copy our s data copy. We'll copy what is ever stored inside of our s value. So we'll have this, we'll have data plus I, and actually this needs to be s copy plus I, because these are dynamically allocated arrays. And essentially what I'm doing here is that I'm copying whatever data is in our stack into our new data copy. And now that this is here, we're going to be copying over the data from our data copy into our actual internal stack. So first we're going to check if our size is equal to 1, because if it is, all we need to do is say that our data is equal to s new s of our s data copy. And because it's a pointer, I actually need to dereference it. And what this will do is that we'll able to dynamically allocate one variable that's going to be initialized to s data copy, and then our internal attribute data will be a container just containing this, right? So our dynamically allocated array will just contain one value, and that value is going to be the singular value that is contained in s underscore data. But if it turns out that s, which we are copying from, is not just one singular piece of data, what we need to do is that we need to copy everything from that array to here. So we're going to say data is equal to s, and it's going to be an array, so we need to dynamically allocate that size, and then we'll copy everything. So we'll have our own data plus I is equal to s data copy plus I. So why am I doing it this way? Why am I creating an extra copy of our s data and then copying the data copy over to where it's supposed to go, its ultimate destination, which is underscore data here? Why am I taking this precaution right here? Well, that's because I'm being extra careful in the copy constructor, but later when it comes to the equals operator, what happens when I set my variable equal to itself? Things can actually get quite complicated because it's dynamically allocated and we're dealing with pointers. And if I'm not careful, I could cause a segmentation fault by pointing to somewhere I'm not supposed to, or trying to dereference a null pointer. But doing this methodology where I take my original data and I copy it to some temporary copy variable that I have here, and then taking this temporary copy variable here and copying it to my real data, this extra step lets me be more safe, and I can actually equate my stack to itself, which is something that I can't really do if I try to set it equal to itself directly, because there might be some problems there. But this is essentially the safe way to doing it. Am I being a little bit too over precautious here? I think so, but I like to keep my code safe than rather jeopardize it. And with ending the copy constructor, I'm going to say our size is equal to s size, and then I need to delete our temporary variable, which is s data copy. So that does it for our copy constructor. Here I have two cases where our s data copy is just one singular value, and where our s data copy is more than just one singular value. They've also considered the case if we have an empty stack, so I think we're good here. So let's talk about our Destructor for the stack class. So one thing that I'm going to do is that I'm going to have an if statement that's going to check two things. One, that size is less than 2, and that data is not equal to null or null pointer. So that we make sure, we're essentially saying that this is going to be a size of 1, but however that it's a size of 1 and not equal to null, because if it's null I don't want to do anything. And if that's the case, I'm going to do delete, and I'm going to delete my data as if it's just a singular variable. Otherwise I'm going to treat it like an array, and I'm going to say delete with my square brackets to delete an array, and I'll delete my data there. Unlike in some of the other classes that we created and covered, the Destructor didn't play too much of a role, but here, because we're messing with dynamic allocation, it is quite important and very important that our stack class deletes this data since it's dynamically allocated. And that's going to cover it for my constructors and my Destructor. What I'd like to cover next is just two more methods, our getters. So the first thing I'd like to consider is a method that I have been using but haven't defined yet, which is going to be my size getter. So I'm just going to return size, and that should be it. And it's important that I define this because I use size in my Destructor, I use size in my copy constructor right here, right when I take the size of s. It's very important, since I've used these and I've kind of assumed that, hey, in the future I'm going to implement these, that I define it here. The next thing that I'm actually going to create a getter for is going to be the top. When we have a stack, let's say for example the stack of plates, the one thing that I'm really concerned about, or I guess the most important thing, is going to be what's at the top. This will allow me to take a peek at my stack. I also may want to have a method, maybe a print method, where I can print everything that's contained in my stack. But another useful getter just for returning a singular value is what's at the top. You want to check what's at the top. What was the last added value that you have added to the stack? And this wraps it up for part 1 of implementing stacks in C++. In the next video, what I'm going to do is that I'm going to go over two methods for adding and removing data, which will be called push and pop respectively. I will also have a print method, and then I will have an empty method, and as well as that I'll add something a little extra, and I'll have a search method so that we can search for values in our stack. Anyways, Stay safe, and I'll see you in the next video.